Now we will talk about grouping and aggregation. Grouping involves categorizing or partitioning our data into subsets or groups based on specific criteria. For example, we may want to group our dataset by the column, that is, the values in the column, and afterwards perform some aggregate functions on it, which brings me to talk about aggregation. Aggregation is the process of applying a function like the sum, average, or count to the data within each group. Once the data is grouped, we can then perform aggregation operations on each group to obtain certain summary statistics or insights. For example, in this data, we have grouped our column by the status, and then we are calculating the mean of each column by that status. What do I mean by this? We'll see, as we've seen earlier, that in our status column, we have different categories of status. Either the order was cancelled, or is in process, or is on hold, or it has been shipped. However, we have grouped our data frame by the status, that is each value of the status, and we are now calculating a mean summary statistics on each column by that status. What do I mean by this? So for example, I may want to calculate the mean of the orders that were shipped, not just the mean of all the sales, but the mean of the sales of the orders that were actually shipped for this column. And as we would see here, that is exactly what we have here. Or for instance, I want to know the mean for the orders that have been on hold. And then this helps us to look at each value of a certain column that is categorized and has been grouped by that column, and then explore the mean. But sometimes we do not want to do this by all the columns. So what we have done here is we've grouped by the status, and we are running the mean on each numerical column in this data frame. So what if we just want to do the mean value for just the sales? That brings me to the next set of code. The difference between the previous code that we have seen is that we have now attached the column that we want to perform the aggregate function to the grouping that we have done. So we first of all do the grouping by the status, and then we say we do not want you to perform this certain aggregate function on all of the numerical columns in the data frame. Rather, we only want to return the summary statistics for a particular column. And that is when we introduce the square bracket, and then we add the column name inside the square brackets. Remember, in the previous one, this is how we have done it. But this time around, we are adding that we want a specific column. This is how we can combine grouping and aggregation. Now, you may wonder, what if we actually want to perform multiple functions? So for instance, I want to go beyond just the average, but I also want to know things like maybe the median value, for instance. That means we want to perform multiple functions on our grouping. So not just one single aggregate function like we've seen here. It's quite easy to do, but we need the help of NumPy to do this. In case you are not familiar with NumPy, NumPy is another Python library like Pandas that is heavily used by a lot of data scientists and even some data analysts. However, with NumPy, when we have installed it, we import it this way and create an alias np, and we are going to see how we would then use it in our aggregate multiple functions. I also have a course on NumPy in case you are curious to know more about NumPy. So I have just done the same thing that we've seen in the previous code. I have grouped by the status, and I have selected the column that I want to perform my aggregate functions. The difference is that I'm not now calling just one aggregate function. I am now introducing a function from Pandas called aggregates. And with this aggregate function, we declare the function and pass in our list of aggregate functions that we want to perform on the grouping that we have done. And as we'll see the results, it has performed us not just the mean as we've seen here, but also the sum. We can pass as many possible aggregate functions inside here as long as they are supported by NumPy. So this is how we see, this is just an extension of how Pandas and NumPy work together. I would advise that if you have not taken my NumPy course, you should also check that out, as it will be very useful for you in the future.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
Now we move to data manipulation. So let's say, for example, I want to manipulate some columns in my data frames. For example, the city column. Let's take a look at what the city column even looks like. In the city column that we will see from the df.head, which shows us the first 5 rows of our column, we would see that the city column is actually capitalized. But let's say, for example, I want to transform this column such that it makes each value in the row all capital letters. This is where data manipulation and transformation comes in. And we're going to slightly see that. So the upper function, as we would know from Python, helps us to transform a string to uppercase, that is, to all capital letters. If we want to do that, we just need to set a variable of that particular column, and then we apply the function to that particular column. As we know, when we pick a column of a data frame, it's basically a series. The reason why I've included the string here is because there are times that we have non-values, and when we do not make sure that our non-values are now strings, let's say, for instance, we have left it, we have not replaced it with any other value, we have left it in our data frame. When we call the Python functions on any row that is empty, as we know, that will return an error. But what I've done here is to include this str command or function that anytime it sees any empty row, is just going to make it an empty string, and we can actually call these functions on an empty string rather than an empty row, because the empty row is returned as none. And that is exactly what I've done here. And as you would see, every row in this particular city is now in capital letters. Let's say, for example, I do not want to override the city. I just want to create another column. The way I would do that is just to do maybe capital city. So it can be any variable that you want, but not the initial variable where you want to transform the column. And then I set that column on that data frame, and I said, take the new value of the transformation of this city into this new column. So this is how to do it if we do not want to manipulate the current column that we have. An example of this is seen in this cell, where I am now applying a lambda function to each row, but I am making sure that the new values are not replacing this column, but they are being saved in a new column. And in case you are not familiar with a lambda function is basically a function that allows you perform row-wise operation on a particular value. You can use it even beyond data frames. The lambda function is not anything that has to do with Pandas, but more of a Python function. And here, what I've done essentially is to reduce each price by 2. So let's say, for example, I want to explore some form of data insight to reduce my price by 2 and see what my new sales price would be if I multiply it by the quantity that I've gotten. I can just do that by applying this lambda function. So I'm saying for every x here stands for every row. For every row, divide the value by 2. When you do that, make sure that it's saved in this new column. So when we return df discounted price, because we have discounted this price by 2, we see a new value of the price. Take a look at the price each. Take a look at the first 5 rows and you will see that these new values are a division of that by 2. And I mentioned earlier that just in case we have not dropped the duplicate in our city, then I have to do the .string, which is what I showed you here before I can apply a particular function. Now I'm showing just another way that we can do what we have done earlier by using lambda functions. Lambda functions basically makes your code easier to read, and I can tell you that lambda operate in terms of computational operations. They are faster than doing it this way. So what we have done here is the same thing that we did above by transforming each of the city to uppercase, but the first thing we did was to drop the non-values. In this case, I don't have to now make each empty value a string because I've dropped them. And then I'm applying my lambda function and saying for every x, I want you to make it uppercase. When we print it, we are going to see what it looks like. I hope you've enjoyed this section. I'm going to see you in the next section where we will start looking at indexing with pandas.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.